first presenter today, I would like to introduce Pavel Odintsov, who will be presenting FastNetMon community open source tool for DDoS detection. Pavel is the founder of FastNetMon and is coming to us today from London. This is Pavel's second time at NANOG, the NANOG stage. His first presentation was at NANOG 88, titled Network Telemetry on Modern Routers in 2023. So we're happy to have Pavel back with us again today. Thank you.
Can I have clicker?
Oh, I don't have the clicker.
So, hello everyone. No worries. So, I'm really glad to be here, and it's a great honor to talk to NANOG audience, and thank you for coming. In this presentation, I will tell you not just presentation, it's just a story. This story started in 2013 when I worked in my very first company. It was a company in cloud compute area. It was basically this story started 13 years ago. It feels like so long time. It was time when FastNetMon was created. FastNetMon wasn't created as a well-scheduled product to solve problem we had in industry. FastNetMon was created as an urgent need to basically keep my own company alive. I remember the time in 2012 when first DDoS attacks started hitting companies. Once, when it started, we had one per 6 months. Then we had one per 3 months. Then we had one per month. Then we had one per week. Then we had 5 per day. And at that period of time, I did my best to find out solution for DDoS attack. I was executive at company. I wasn't positioned myself as an engineer, and I did my best to find out all the possible solutions for market. And I had meetings with every single vendor available in my region. Back in time it was in European Union, and I did my best to find out best solution for us. And unfortunately, it was harsh reality that because my company operated in low margin market of virtual services we provided for customers, the cheapest solution we had back in time had incredible capacity of 10G of scrubbing. And we already had attacks of something like 45G, it was a lot of traffic. But the main problem was a cost. And cost actually was on the same scale as annual turnover of my company. I would say the company wasn't that successful, but we did our best, we did our place, and we had lots of customers, happy customers. But problem was, financially, it was impossible to buy any solution. And we had hard choice, because company was going back to bankruptcy. Because every single time we had DDoS, we have tried to solve it manually, we have tried to stop it somehow, we used different tricks, again. And then, by the end of the day, we lost a few customers. Then again. Then again, then again. And basically all growths we were getting, we were losing because of DDoS. And that's actually how FastNetMon was born. I had no choice but start and develop a tool which will help us with handling DDoS, doing it very fast and affordable way. What is FastNetMon? FastNetMon is a tool. You can install it in your network, you can run it. To run it, you can use any operating system, which is Linux, macOS, or FreeBSD, or OpenBSD, or basic any kind of platform you have at your disposal. And second thing about FastNetMon is real, pure open source. It's based on exactly same license as Linux core. No strings attached, no constraints, no BSL, business licenses, no limitation, no doubles, nothing. It's fully and entirely open source. And what kind of DDoS we can find, and what kind of DDoS we can fight with FastNetMon. And I'm really glad to have lots of people in the room. And I want to be more specific. That's exactly type of DDoS you're dealing with on a daily basis. So it's L3 DDoS attacks, L4 attacks, using IPv4 protocol and IPFIX. I don't like very much classification of DDoS attacks, because classification of DDoS attacks is telling nothing. Really, let's imagine water torture. What does it mean? How it's implemented? For reality, for network engineers, the only thing we care, what kind of field attackers change it to implement this specific attack. And basically, attackers can change almost every single field in headers. What we have here. Everything can be changed, forged, manipulated. Maybe they even have to keep destination IP address, but that's all. Everything can be changed, and if a huge amount of traffic can be generated, then it will be DDoS. IPFIX. In IPFIX, we have slightly less fields, but again, every single field can be used to run attack against your network. So we support all of them. If we go slightly deeper in protocol stack, and let's look on level 4. In level 4, we deal with UDP attack, TCP attack, ICMP most of the time. And so, at this point of time, we just have a scope. What kind of DDoS we're dealing with? And it's exactly the same scope as what we're dealing with routing. To route traffic, we need to have source IP, destination IP, some flags, that's all. That's exactly kind of DDoS which poses a real threat for networks. And for FastNetMon, attacks against website applications is entirely out of scope. We build and we provide solution only for protecting networks, not for protecting endpoints. And usually you may hear that those attacks, what I tried to explain, they're called different flood attacks, and I would say in total we can summarize that FastNetMon is a solution to fight volumetric attacks. DDoS attack may be small enough, smallest scale, for example, like 100 megabits, few hundred megabits, but real ones, which pose any real danger for networks, are huge. And back in time, huge was 1 gigabit, 10 gigabits. And last one, what was reported by one of our customers, was 35 terabits. And packet rate was just incredible. And we had to actually change our product, and we had to change unit, because previously we used units for packet rate measurements as a packets per second or megapackets per second. And we had to actually introduce new one, gigapackets per second. And last attack we had, which was largest detected ever by our customers, it was 1.5 gigapackets per second. And that's a scale which poses real danger, not only for targets, not only for endpoints, but also for transit networks, because it's a huge amount of traffic. And we hear a lot about DDoS attack, but it's great to see what's happening in dynamic. In dynamic, and what we can see exceeds our worst expectations. We never expected to have 35 terabit attack in 2025. We never did. Our expectation was, okay, maybe we will have something like around 10 terabits. And dynamic of growth of attack. It's not exponential yet, but you can see numbers. We started from 300 something, and now we're talking about 1,000. And this data is kindly provided by Dutch non-for-profit institution called BIPNAVAS. They're really great, they share a lot of data, and they're really good about measurements, about dynamic of DDoS attacks. And I'm sure you can correlate it with your experience. And at the same time, still most popular and most dangerous amplification attack type is DNS amplification. There are lots of new attack types, and we all heard about ICRobotnet, which actually quite new attack type, which is also a volumetric one, but it's not amplification. So previously, major risk for networks was amplification attack, but those days, real attacks coming from non-forged, real IP addresses, mostly coming from countries like Brazil, different places in Latin America, in Asia, and it was real danger. So we still have DDoS problem, and we will have more DDoS problems. And I remember having exactly the same presentation 10 years back, and I had to explain what abbreviation of DDoS means. Now I don't need it, and everyone knows about it. I would say DDoS, unfortunately, has become household name. Even people outside of tech industry, they know what is DDoS, they can explain, they do understand. And it's really sad, but at the same time, I would say I like to look on positive side. Ability to run 35 terabit attacks means that we build incredible networks across the planet, which can carry way more, orders of magnitude more traffic, and they do it reliably. So it's just function how internet grows. So better attacks, better internet. And from perspective of FastNetMon, when we started, we tried to avoid making implementation specific for any vendor. So from day one, FastNetMon was vendor-neutral solution. And we try to just follow RFC, and if vendor follows RFC, then it will work. Otherwise, it will not. And by doing so, we got quite large test base. We had a lot of different vendors, different software versions. We engaged with so many different vendors in fixing their issues, with reporting their issues, implementation. And we can declare, so basically FastNetMon is well supported by basically every single vendor you can find in your network. Maybe even old ones. And that slide, I'm very proud of it. And in total, for FastNetMon community, we have more than 21,000 of confirmed deployments across the planet. Every single place, with small exceptions of Antarctic, we do have users using FastNetMon. And I'm really proud about this part because I remember that feeling of being unable to defend my company. I had no options to buy solutions for it. And FastNetMon was built with idea to provide solution for DDoS protection to everyone, accessible, versatile, and compatible with basically all the vendors we have on market. There are multiple key features on FastNetMon. One of them, my favorite one, is detection speed. Because modern attacks, they can saturate even the enormous capacity you have. Let's imagine you do have 1 terabit of capacity. I don't think that so many people here may have 100 terabits, but still, there are different cases, and 1 terabit is still more than enough. But issue with modern attack, we can see, they may start from 100 gigabits. Few minutes later, it's 500 megabits. 5 minutes later, even faster, they may reach hundreds of. And problem is, we have to stop DDoS attack very fast. Any hesitation, any delay will lead to congestion. You may have a lot of capacity, but again, problem with I0, for example, that most of the traffic for initial attack we reported was coming from Brazil. And usually, you don't keep terabits of connectivity with Brazil if you don't have Brazilian customers. So from Brazilian companies, it's fine. But usually what we face, it's mostly for European companies and American companies, they didn't have that capacity. And so it immediately caused congestion on their upstream connection, which was hiding and processing traffic from Brazil. And even with I0 botnet is also a very important topic that many different companies, they reported attack levels on slightly different scale. Some of them reported as 10 terabits, some of them reported as 20, some of them reported as 30 something. But the issue is, it's just a function of connectivity. Some companies had no ability to actually receive all the traffic, to see full attack, because their link congested way before actually attack reaches saturation point. And FastNetMon is very fast. And we work with state-of-the-art protocols. By saying state-of-the-art, I mean such protocols as IPFIX 315 from Cisco, IE315 from Nokia, which basically was released in mid of December, and or inline monitoring services from Juniper. And those, or one of the favorite protocols we do have, which was before, it's sFlow. And those protocols, they offer exceptional detection speed, because we receive information what traffic was observed by router, not with delay of few milliseconds, and then we can make decisions as fast as we can. NetFlow protocols, IPFIX family of protocols, which engage aggregation, which involve delays. We call them legacy. And some people may be offended by it. But what we can see, and what level and scale of threats we can see with modern DDoS attacks, and absolutely unacceptable to keep protocol in your network which has delay of reporting time of 30 seconds, and which actually itself may become bottleneck, which may cause more degradation in your network than if you didn't have one. So we do recommend you to look for different protocols, and inline monitoring service, IPFIX 315, they're great protocols because they don't have any delay in reporting. As soon as your equipment observed traffic or routed it, you will see information in FastNetMon or basic any tool which you use for traffic visibility. And second advantage of FastNetMon that we actually tried hard to avoid asking you for changes in any network, because your network is here, it's already built. And who we are to ask you, okay, you need to change your topology to effectively high DDoS. Not going to happen. Or if we tell you, look, you need to change vendor to better fight this, again, it's not happening. And FastNetMon was built with idea to adjust to existing environment. You have 5 vendors, fine. You have all these specific Cisco box, fine. And we support all of them. And at the same time, in FastNetMon, because of our dependencies on RFC compliant protocols, we do our best to extract as much as possible information from telemetry itself. And that's why to make configuration of FastNetMon, you just need to change 6 configuration options. That's all. You need to enable specific protocol which is supported by your equipment. You need to enable detection. You need to specify what kind of actions you want when we detect attack. And that's done. Everything, no low-level configuration, no tricky options, no engineering options, nothing at all. You just enable it from your router and it works. And we support basically every single Linux distribution. Every single of them. And I would say thank you to our maintainers, because there is a team of people from different distributions such as FreeBSD, OpenBSD, Debian Linux, Fedora Linux, Ubuntu Linux, working without basically any compensation for making and delivering FastNetMon to all those distributions. And to install FastNetMon, you don't need to go to our website. You don't need to check our installation guideline. You just use your standard packet manager in your Linux distribution and install it. To make it possible, we spent 6 years, because some distributions, for example, as Debian, they're not moving very fast, and we need time for making it possible. But the point and idea was, because I remember being same person, sitting in cold, noisy data center, and trying to find out what is the tool to detect DDoS attack. I tried to find out, okay, what is documentation? What is the way to install it? What is the way to compile it? And everything was falling apart. And I don't want for anyone to be in this position, apt-get, install it, or yum install, FastNetMon, and then it will be here. And if we want to run latest version of FastNetMon, or for some reasons your distribution is not supported, we have install tool. And install tool is not doing any kind of magic. We just detect what is your version of distribution and install binary packages built specially for your machine. And so it's simple as it is, just one command. But in majority of cases, you don't need it. Of course, we do have a lot of improvements in FastNetMon, but in majority of cases, if you're looking to solve your immediate problem, FastNetMon, best option for you to install it from your distribution and then enjoy it. And the detection time of FastNetMon depends on equipment you have. I cannot guarantee that for all equipment we can offer 1 second detection. Unfortunately, we cannot. Because again, for example, if you use NetFlow, we are constrained by NetFlow timeouts. We cannot do it faster. But if you run samplet mirror, or you run state-of-the-art inline monitoring protocols, or IPFIX v15, or sFlow, you can expect that FastNetMon can detect attacks in as short as 2 seconds. And the thing, very funny thing about FastNetMon is that it's actually one of the advantages what we have over many competitors, even commercial companies. And some customers actually complain that FastNetMon detects attacks too fast. It's too sensitive sometimes. And in some cases, if you have a lot of capacity, you may actually artificially need to delay it, because you may not care about attacks that fast. And there are many ways how FastNetMon can get information from your equipment. Basically, we support all known protocols for traffic telemetry, including vendor RFC compliant ones, as NetFlow 5, 9, IPFIX, inline monitoring service, IPFIX v15, sFlow version 5, different types of sample port mirroring, very exotic protocols, for example, as Nokia shim protocol, which basically exposed low-level structures delivered via UDP, because we just try to find out what's the best and fastest way to do it on such platforms. And everything you have on your equipment very likely can be fed to FastNetMon, no matter what. We don't have constraints. So if you have old firewall, support only NetFlow 5, fine. It will work with FastNetMon. And there are plenty of attacks which can be detected by FastNetMon, and basically every single attack which involves layers 3, layers 4 can be detected by FastNetMon. And For IPv6, we have native support for IPv6 for more than 5 years, and it works just fine. But fortunately, we don't see that many IPv6 only attacks, but it just functions. Maybe just a fraction of traffic which is coming over IPv4 as attack, because it just sometimes bad guys, they don't care about checking what is the protocol they're using. And we can expect more, but at the same time, you already defended from attacks if they start coming more frequently via IPv6. And scalability, on this presentation you can see quite shy numbers, but you can see I just shared what we had. We had customers 1.5 gigapacket per second attack, and FastNetMon is very fast solution. FastNetMon is implemented in C++ and it scales very well. So basically, if you run enough CPU resources for a machine, you can expect for FastNetMon community to handle multi-terabit network without any issues. It will work just fine. Outside of box, you don't need to change any configuration, to change any database. You just run it, allocate enough resources, and it will work just fine. And what FastNetMon can do, and as soon as we detect DDoS attack and confirm it, we can run different actions. And most popular action for us, because we are all network engineers, is a BGP. We can communicate to your network via our bundled BGP daemon and inject information about what prefix is under attack, what host is under attack. And by having so, we also provide additional information, for example, as additional community numbers, next hop information, and then you can apply routing policy changes in your network as soon as you receive information from our side. And if it's not enough, or you do have your custom system for network management and notification, you can run just script, or we can send information about everything we know and everything we learned about attack into JSON packet via HTTP. And then you can run decisions according to this information. And there is a nice addition on top of DDoS detection. Since early days, FastNetMon had no user interface, nothing at all, no way to tell that it's working or not. It was just the way you just set it up, you set up thresholds, and you keep it this way. But as soon as you got first false positives, or as soon as you get real DDoS attack and you want to confirm it, you need graphs. And that's a great advantage of FastNetMon. We have lots of reports, and those reports are implemented for now in Grafana. And we do export data into different, I would say, industry standard databases, such as InfluxDB, ClickHouse, or Prometheus. If you do have existing system, you can export information from FastNetMon about all traffic measurements, all traffic reports, without any changes in your infrastructure. And great benefit about all reports provided by FastNetMon that, again, it's close to real time. The second you can see spike, which may be malicious or not, you will see it on our graphs. There is no delay in updating information. And you can see we have different level of logical, I would say, aggregation. So we do have reports for total traffic. And then if we go deep, we can find out what is the bandwidth for different prefixes. And in the same time, it may be not only bandwidth, it's also packet rate for different prefixes. And then we go deeper, we can find out what is the bandwidth for this specific /32 or /128 in this specific network. And this information is absolutely crucial to, at the same time, to monitor for your network well-being without any delays, because you may rely on different systems, but what we notice is that so many systems, they do have delay, which is significant. They may be based on old protocols, they may have delays for aggregation, and that's why we had no different option but to implement traffic measurements and traffic reports inside of FastNetMon. And this data is very efficient, and it can be used for DDoS detection. And of course, it also can be used to learn more about what's going on in your network, and actually it will be very helpful and useful to actually find out what is a baseline for your network, what is the normal traffic for your network. And to install FastNetMon, again, it's exceptionally simple. You can use our install tool, or you can download it from your distribution, and it works just fine. And to finish initial configuration, you don't need more than 15 minutes. That's all. That's exactly timeline you have with modern DDoS attack. If you hit by DDoS attack right now, you have enough time to deploy everything, test it, try it, at least to see what's going on right now. You don't need to enable complete detection of traffic, but then as soon as you deploy FastNetMon and send NetFlow information to FastNetMon, you will be able to say, okay, this is a prefix which is under attack, or it's the host which is under attack, and it's exceptionally valuable. Because I remember my times back, and again, sitting in cold data set and opening TCP dump to find out, oh my god, is it target of attack or not? Is it target of attack or not? It was very stressful, and I wouldn't recommend to everyone to repeat this kind of experience. And detection logic of FastNetMon is very simple. You just set thresholds for every single host in your network. You can set, by default, we use exactly the same thresholds for all the hosts in your network. For example, you do have customers which have bandwidth allowance for their plan is 1G. And then you can set on FastNetMon that if their traffic exceeds 1.1 gigabit, which will never have happened during normal circumstances, but under DDoS circumstances it may, then FastNetMon will find out and it will notify you. Internally, FastNetMon works by recalculating traffic for all the hosts, all the IP addresses, all the prefixes you have in your network every single second, and if it notices that some type of counters exceed value set in configuration, it will notify you or it will deploy BGP announcement. And there are plenty of thresholds we support. It's different one for protocol based, it's total one, it's packet rate based, it's flow based, and in addition to it, you may create custom thresholds for different prefixes in your network or different hosts in your network, basically just to reflect complexity for a network. Normally, I would say for production deployments, our customers use no more than 20-25 different profiles. For example, they do have mobile customers, they do have broadband customers, business customers, caches from different providers, and all of them need slightly different configuration side. But at the same time, you don't need to guess what is the baseline, because data is here, and it's stored in databases, and it's stored in Graphene, and you can open specific prefix and look what is the peak traffic for this one, and then set data accordingly and set threshold to some value which may pose danger for a network. And a very important point about, especially in context of I0 attacks, is that FastNetMon can detect not only incoming DDoS attack, but also outgoing DDoS attacks. FastNetMon can equally apply to incoming traffic or outgoing traffic, but for I0 attacks, what we heard, and we had multiple customers approaching us in a way how they can fight efficiently, because botnets for I0s, they can generate enormous bandwidth, and there may be so many hosts and customers in your network which may be part of I0 botnet, and when they start attacking somebody else outside of your network, of course your network will not degrade because you have a lot of capacity and outbound traffic is usually not under pressure, but at the same time it's about being good citizen, being good part of internet, because you don't want to be in position when you got hit by this kind of attack. And that's why we do recommend for everyone to deploy not only incoming DDoS detection, but also outgoing DDoS detection. Because just to understand if something going on in your network, at least you will know. What you can do next, it's an open question. You cannot block it, of course, but you can find out, you can notify customer, you can look inside of it. What is it? Is it legitimate or not? How bad is it? And we have lots of interest in especially outgoing attack detection over last year. And at the same time, FastNetMon, we position FastNetMon as on-premise product, first of all. But at the same time, we live in real world. And FastNetMon is not capable to solve all the issues we have with DDoS. We do have we may apply for BGP Blackhole inside of network, and we may move traffic which is under attack or prefix which is under attack to equipment allocated for DDoS scrubbing in your network. But at the same time, at some point of time, we had to say, and we reach capacity of our upstreams, and we had no choice, but we have to move traffic outside of it. And that's why FastNetMon also has an option to move traffic away from your network entirely. So if you do have a contract with external scrubbing center, FastNetMon can help you to engage those centers. we use it via BGP or via API, and we support more than 15 different scrubbing centers via API. And by doing so, we can enable DDoS protection, and we can enable prefix announcement outside of your network. And then by doing so, FastNetMon can move traffic from your network on demand. And so instead of sitting here and looking when your network got attacked or using always on, you can just delegate this task to FastNetMon. And you can set threshold, which is really high to understand, like, okay, my network has no such capacity, and I have no different choices but to move traffic away from my network. But as soon as FastNetMon detects this spike of traffic, it will move it away to scrubbing center, and then in definite time limit, it will move traffic back. So no human interaction required first. So you can handle it entirely automated way, without any engagement of people, without any confirmation. You don't need to confirm it, you don't need to monitor it. It will work outside of the box and entirely automated way. And main purpose and majority of people who use FastNetMon community, they use it for RTBH, and RTBH is a very effective way, and it's very affordable. And I heard many objections from people, because when I tell, look, RTBH and Blackhole is a way to defend attack, some people will claim, okay, you're just basically pulling the cable from customer. And from our perspective, we have obligation to run networks. And point why FastNetMon was built is to keep network running. And if we have hundreds, thousands of customers, and then we had one, which may cause degradation for all of them, all remaining customers, we have no choice. We have to make hard decisions. We have to pull plug from this specific customer. It doesn't mean that we keep it this way. It means that we just got more time. So we just reduce urgency from P0 outage to maybe P1, and we'll have more time. And then we can decide what we are going to do with this specific service which is under attack. And there are plenty of ways what you can do. You can move it in scrubbing equipment inside of your network. You can move it to your specific upstream, which has DDoS protection. And this case is actually growing for FastNetMon, because actually many ISPs and upstreams, they actually offer DDoS protection. But usually you don't have all of them, and you do have internet exchange connections. And in case of DDoS attack, let's imagine you have 3 upstream connections from different carriers, but you do have DDoS protection only from one of them. And still, you do have protection, but when attack will start coming, you will have it from all of them, including not protected ones. And this way how FastNetMon can help you as described exactly on this slide. So this case is very similar to option when you move traffic away from your network by announcing /24 externally and moving traffic around or withdrawing prefixes from your network. But in this case, you can just move traffic away from all remaining upstreams and focus and push traffic to come over specific upstream which has DDoS protection. And by doing so, again, you entirely eliminate need for human interaction. You don't need to open your configuration of your routing. You don't need person to monitor it. And again, it happens entirely automated way. And because of use of FastNetMon, you can reduce time how long you use this DDoS protection. Because I have to admit, every single time you engage cloud scrubbing services, or you engage DDoS scrubbing from your upstream, there is an impact. For its negative impact. You may have false positive. You may have more traffic filtered out. For DDoS scrubbing centers, you may have your traffic moved away to regions which are far away. In States, it's not a problem, and for example, but in many regions in Asia or Latin America, moving Mexican traffic away to even, for example, Brazil, it's going to break almost everything, and customers will notice latency, customers will notice more issues. That's why we do recommend to use it only when absolutely necessary, only for a short period of time. And when FastNetMon detects attack, we provide very detailed report which has lots of counters, measurements, and we provide full attack sample, which includes all the traffic which was observed by FastNetMon when we detected the DDoS attack. And simplest stuff, and to integrate FastNetMon with your existing network management solution, you can just run Bash script or Python script or Perl script. It depends on your own preferences, and FastNetMon can call it and pass all the information we got about attack to your system, and then you can propagate it, and then you can apply different policy changes. You may notify your network engineers, you can notify specific customer about what's going on. It's especially very important to propagate this information as soon as we can, because the more people are aware that you are under DDoS right now, even if you don't have any automation, it's exceptionally valuable information to learn, okay, there is a problem, we need to look on it. And then very likely we'll have lots of alerts from different monitoring systems, and FastNetMon at the same time will just confirm, okay, it's DDoS attack. Because so many cases we had in our experience that people spent hours trying to find out what was the root cause. Was it configuration implicit damage? Was it routing changes? Was it outage on ISP, or was it real DDoS attack? And by providing lots of reports from FastNetMon and provides this kind of notification, we answer question almost immediately. As soon as you got lots of malicious traffic, you get notification. And then it's up to you to apply custom actions, make decisions. And as a conclusion of my presentation, I would like to say that the only way how we can fight DDoS is by collaboration. There is no single company, there is no single entity, there is no single government who can actually say, okay, I can fight DDoS. DDoS can be defended, and we can reduce impact from DDoS attacks by collaboration. And it's our part. We provide a tool which can be used to effectively mitigate attack. But there are lots of components. There is a lots of approaches how to, for example, how to avoid attacks which involve malicious traffic from your network, how to validate routing security policy, how to apply RPKI, how to apply madness, how to filter out malicious traffic from your customer, how to apply better policy checking for routes announced by customer, how to prevent hijacking. And I believe in collaboration, and I'm very open for any feedback. Personally, I'm really passionate about DDoS in general, traffic telemetry, all of them, and BGP routing security. And if you have questions, topics to discuss, I will be happy to chat about it, and you can find my contacts. And this slide is a list of all the communities we have for FastNetMon. In FastNetMon, we have more than 2,000 people via different channels. It's Discord, IRC, Google Groups, Slack rooms, Telegram chats, of people who are somehow very passionate about DDoS. Some of them just love looking what's inside of it, just debugging problem. Some of them just hit by DDoS in the middle of net and asking for questions. It's a very knowledgeable community. It's a great community. It's a very kind community. And if you have questions, please join and share your experience or ask for assistance. If you have specific case in your specific region, you can ask, okay, do we have any way to mitigate attack in this specific region with this specific ISP? Very likely, you may expect answer. And I would say it's a go-to community for questions about DDoS. And I will be very glad if you join it. Thank you very much for listening.
Thanks, Pavel, for the interesting talk. Is there any questions that anyone wants to bring up? We've got a few minutes before the next talk. Yeah, I'll go up to the mic, state your name and affiliation, and then...
Hi, my name is Omri with IceNizy. So when you set the thresholds for a single host, are you able to consider the dynamics of use case around like the time of day? We have, for example, 8 a.m. Or 9 a.m. trading starts, and then we got a spike of logins, and then at the end of the day, when all of end-of-day reports, then was a spike, but throughout the day it's kind of mellow. So how do you handle like dynamic, over time thresholds for those kind of?
So unfortunately, there is no easy way to handle this kind of dynamic, and basically our recommendation is, first of all, you deploy FastNetMon for at least 1 week, and the requirement of 1 week is exactly for that reason. We have to cover peaks, and in configuration, you have to set baseline to value, which is maximum and peak time, because it's quite hard to make configuration changes every single day, and still, despite of very main focus of FastNetMon automation, we still do recommend to have human confirmation and review for thresholds. Because problem is we may capture, like if you do it fully automatically, we may have risk to actually block and capture DDoS or malicious traffic at the baseline, and then we can set baseline, okay, 100 gigabits, which is not okay. Yeah, this case quite complicated, but what we can recommend normally is to find out what exact traffic is legitimate in your case. It may be, for example, it may be very likely it's TCP traffic, and you do understand what is a normal baseline for you in packet rate, because malicious traffic is quite different from legitimate ones. So you don't have that very high packet rates or number of flows for legitimate traffic. And that's why we recommend not to look on bandwidth, for example, but to look more on packet rate or flow per second rate, because it's a better way to say this is not normal traffic. If there is a spike, it may be caused by legitimate customer, but because of its nature, it's dynamic. It's like very large packets, or on contrary, very small packets, or specific protocol you don't expect it. That's what we recommend to do so.
Hi, Becky Russ from ISC. I have a lot of questions, but just try to stick to a couple. I'm so impressed. I've been watching this project for years, and the way you have expanded it and supporting so many operating systems and so many platforms, very impressive just from a maintenance perspective. So
thank you very much.
Congratulations for that. I'm curious to know, what are the differences between your community edition and your advanced edition? Is there an easy answer to that? Is it scalability or features?
Yeah, I would say from perspective of code, there is lots of shared code. So because, for example, between commercial edition and free edition, we have absolutely identical logic for handling BGP protocols. We have absolutely identical logic for handling sFlow protocols, NetFlow protocols, IPFIX protocols for port mirroring, tap mirroring pipeline. But commercial edition is focused more on very sophisticated cases and very complex networks. So what I explained in community edition, you may create 1 or like 10 host groups, but in commercial edition, you can create thousands of them. And they may be dynamic, they may have a lot of different configuration options for specific type of traffic. For example, you can create threshold for number of packets with very small TTL. And I would say commercial edition is main focus for very, very large networks. But I'm not saying that community edition cannot handle big networks. So we have customers with networks exceeding a few terabits of capacity using community edition without any complaints about performance or capabilities. It's just more about how complex your customers are, how easy you can explain your threshold, how easy you can explain your traffic profiles to product.
Well, I'll ask another question since I don't see anybody else at the mic. I'm curious if you mentioned that you do detection of DDoS attacks versus DNS. How do you discriminate the abuse traffic from the standard traffic when it's DNS?
We don't, because for FastNetMon, DNS is out of the scope, because we don't work with application level protocols. We do look on DNS from perspective of DNS amplification, and majority of cases it's malicious. And for us, how we distinguish legitimate DNS traffic from not legitimate. Legitimate is less than 1 gigabit. Illegitimate is on scale of hundreds of gigabits. That's how it works for now. And so
you just look when there's a spike and you just cut it off, basically.
Yes, absolutely. We look only on bandwidth numbers. So for us, it's too much, then we cannot do anything. And generally speaking, I would say DNS protocol is a very tricky protocol to actually defend from DDoS attack, because it itself looks like DDoS attack. Yeah. Especially if you have huge amount of requests. It's small one, UDP one, and frequently it may be fragmented.
Okay, thank you.
My pleasure.
I think that's it. Thank you again, Pavel, for a great talk.
Thank you very much.
Would invite some